So I hope my screen is visible. The PPT, is it visible?
Yes, sir.
Fine. So first we will be discussing about measurement and scaling. Why this is important? Why we should start with measurement and scaling? Because it lays the basis of our statistical test. Most often, I have found people jumping on a statistical test or deciding on a statistical test because somebody asked them to do that test. And at the end, they are stuck in between. Because there is a scientific method to follow whenever you go for deciding on a statistical test. And it starts from what kind of variables you have and how these variables have been measured. So basically, when it comes to the variables, we either have a categorical variable or a continuous variable. The categorical variables are also known as non-metric variables, and continuous variables are known as metric variables. So if you have measured some data on a nominal or ordinal scale, then they are classified as categorical variables. If you have measured your data or collected your data on the interval or the ratio scale, then they are known as the metric or continuous measurements or metric variables. A very basic difference between these nominal, ordinal, interval, and ratio, I hope many of you might be aware of. Just to recall, nominal variables or nominal measurements are those which are used only just for identification purpose, like roll number of a student, gender, for which you cannot compute any mean value. Only you can do frequency counts. Second one is the ordinal variable, where you put things in a logical order, like good, better, best, bad, neutral, good, something like this. So whatever we use on a 5-point Likert scale is more of a ordinal variable. Strongly disagree, disagree, neutral, then agree, strongly agree, like that. But the distance between these is not equal. They are in logical order, but the distance is not equal. When you create equal distances, means the difference between good and better is same as the difference between the better and best. Or when you you are taking a Likert scale, when the difference between the strongly disagree and disagree is as same as agree and strongly agree, then it is known as the interval value. And when you take the absolute values, like height of a person, temperature of a body, something which is a very absolute value, then that is known as the ratio variable. The ratio variable is the highest level of measurement, or the ratio measurement is the highest level of measurement that we have. So, again, to sum up, if you have a nominal or ordinal measurement, they will fall into the categorical measurements. Here you can apply frequency distributions, to some extent a few tests, but if you want to apply something like regressions, if you want to apply a parametric test, then your variable should be either interval or ratio. Means they should be metric in nature. If all of your dependent or the independent variable are nominal or ordinal, then they will pose a serious problem for you when you want to do statistical test. And most often what happens, that without seeing that what kind of variable we are having, we try to uh, do a statistical test. No, the basis is the measurement. And how come this basis is the measurement? Because for parametric tests like t-test, ANOVA, or correlations, one assumption that is known as the normality. The data should be normally distributed or following its spread should be following a bell-shaped curve. That is required. When you are taking a categorical variable, that is nominal or ordinal, since it's categorical, so it will always be skewed. It cannot be normally distributed. And if it is not normally distributed, then of course you cannot apply a parametric test. When you are taking an interval variable and ratio variable, of course, they will be, there are chances of their normal distribution, and then you can apply a parametric test. But it is not the case that you are taking an interval or ratio variable and without checking for normality, you assume that it is since a metric variable, so it will be normally distributed. No, you need to check the normality. But if you are taking a nominal or the ordinal variable, that is categorical variable, don't waste your time even to check the normality. They won't be normally distributed. Because the rule of normal distribution says that few will be, let's say, if you have uh, uh, measured height, so some will be short heighted, some will be long heighted, and most of them will lie in the center, that is the average height. Then only this normal distribution will be fulfilled. When you are having categorical variable, either they will be short heighted or long heighted. Right? So the population parameter estimate won't be fulfilled to follow a normal distribution. But yes, if it's an interval or ratio, then you can check for the normality. So this is once you decide on what kind of variables you are going to measure, then how you will measure these variables. The second step, which scaling technique will you use? Whether you will be using a comparative scale or non-comparative scale. Again, there is a problem which I have found with most of the people. A comparative study of two companies or comparative study of buying behavior of two cohorts of people, two different sets of people, let's say means based on gender or age group, generation X, generation Y, a comparative study or comparative study of two products. The moment you are saying that you are doing a comparative study, please don't use a Likert scale. Because I've seen people using Likert scale in a comparative study. No. When you are comparing on some estimates or on some parameters, two sets of populations or cohorts or products, then non-comparative scale should not be used, and Likert is a non-comparative scale. You should use the comparative scale, which are paired comparison, where you put uh, you put both the products and compare them side by side. Rank order, where you rank them from 0 to 100, sorry, in the order of preference. Constant sum, where you give them numbers from 0 to 100, and Q short and other procedures. If your objective is not to compare, then only you should use non-comparative skills. Again, they are continuous rating skills and itemized rating skills. Continuous rating scale is means there is no neutral point in between. It ranges from 0 to 100 at equal distances. And when you want to measure attitude, opinions, perceptions, then use itemized rating scale. And most often, one of the most often used itemized rating scale is the Likert scale. Otherwise, you can have a semantic differential scale also and a step scale. So these two things you need to keep in mind, your measurement and your scaling. And why it's important, I'll tell you with the help of this decision tree. Because whenever we go for deciding on a particular statistical test, we arrive at that statistical test not on the basis of our whims and fancies, but on the basis of some statistical rules, right? So let's say you have a dependent variable. Okay, quickly, I'll just talk about variables first. So these are important. There are many types of variables, but most important we use are the main variables and intervening variables. These main variables are those among those on them we try to find the relationship. So basically, they are dependent variable and dependent variable. These are our main variables of our study. So whenever we are deciding on our dependent variable and the independent variable, again we should take proper caution that these variables should be driven from sound literature review. What other studies are suggesting? Because whenever we are trying to find a relationship between a dependent variable and independent variable, we are trying to test a theory. And from where that theory is coming? That theory is coming from our initial observation as well as the observation of others who have done this similar study in the past. So we have to very cautiously choose our independent variable and dependent variable. If not chosen properly, they will always create a problem. Then the relationship between these dependent variable and independent variable is often affected by some other variables. These variables might be exogenous or endogenous. Means either they are out of the system or they are from within the system. If they are exogenous variables, they are known as mediators. And if they are endogenous variables, they are known as moderators. About these mediation and moderation will be coming to know after the regression. So just in a nutshell, if there is a independent variable and dependent variable, no relationship happening between them, then you are bringing one variable from out of the system to create that relationship. And that variable which is which you are bringing from out of the system is known as mediator, and such kind of relationship is known as mediation. There is a variable that is present in the system already. It is changing the strength and direction of the relationship between the dependent and independent variable. Then that variable is known as the moderator. It can increase the relationship or decrease the relationship, or in some cases even end the relationship. So that kind of relationship is known as moderation. Now, let's say there is a situation that you have a dependent variable. So dependent variable is largely the variable that is getting affected, and independent variable is something which is causing that effect. So if you are trying to find a relationship between a dependent variable and independent variable, then independent variable will be the variable that is causing the effect for the relationship, and dependent variable will be the variable that is causing the that is getting affected by the relationship. Now let's say you have one dependent variable and one independent variable. Your independent variable is divided into two categories. Let's say, and then that two categories are independent of each other or mutually exclusive. For example, I want to test the preference towards fragrances among male and females. Now, what I want to study, my dependent variable is the preference towards fragrances. Independent variable is gender. Now, this gender is divided into two categories, male and female. Both are mutually exclusive of each other. Means their characteristics differs. In that case, it will be a case of independent sample. Now, to test this relationship, test this, whether male have preference to, whether there is a difference between the preference of male and female towards a particular fragrance or not, I have to apply a independent t-test. But should I directly jump onto independent t-test? That's the point in question. So before that, I'll see how I have taken my measurements, whether it's a metric measurement or categorical measurement. I mean to say, so here k is equal to 2, that simply means that I have two groups, means my sample is coming from two different populations, and the population is mutually exclusive of each other, that is independent, a male population and the female population. And then I have fragrances. I have to see that my dependent variable, whether it is metric in nature or categorical in nature. Suppose if I have taken data like would prefer, won't prefer that particular fragrance, or least prefer, likely prefer, most likely prefer. This is the categorical measurement. On the other hand side, I ask them to give a weightage or marks to their preference. Let's say out of 100. That makes it a metric data. So if it's a categorical data, my measurement is categorical. I need to do nothing rather than I have to switch on to the non-parametric equivalent of the independent t-test, that is the Mann-Whitney test. However, that's why I'm saying where is the importance of the measurement? Because if we are doing wrong at this first very step, the measurement, our entire study will go wrong. Now let's say I have taken on absolute values, absolute scores of their preference, which is a metric data. Then of course I will check for whether the data collected is normally distributed or not. If it is a categorical measurement, then even I do need not to check the normal distribution. Already I told it won't be normally distributed. Directly I have to move on to the non-parametric equivalent, that is Mann-Whitney test. But if it's metric, then I have to go for checking the normal distribution. If the data turns out to be normally distributed, fine, move to the next step. If not, then again I have to move to the non-parametric equivalent of t-test, which is again the Mann-Whitney test. Now, suppose if the normal distribution is situation is fulfilled, but since I have population coming, I have data coming from two different populations which are mutually exclusive of each other, then I have to also check whether there is a homogeneity of variances or not. Means the change in perception that I want to measure, whether this change is happening both in male and female or not after being exposed to that fragrance. Let's say I have exposed both male and female to a particular fragrance, same fragrance, and change is happening in the perception of male, and there is no change in perception of females. This could be one situation, and second situation could be that I have only exposed males to that particular fragrance, females to, let's say, to no fragrance or a different fragrance. Then the change that will happen won't be equal, means there won't be any homogeneity of variance. If there is no homogeneity, variance must change from its mean value. So if there is no homogeneity of variance, then again I have to move on to non-parametric equivalent. But if there is a homogeneity of variance, means change is happening or exhibited both in male and female towards their perception or their likeliness or their affinity towards a particular perfume or fragrance, then this is the situation where homogeneity of variance is established. And we do this by Levin's test. If this situation is fulfilled, then finally we will move on to the applying independent t-test. So just for one test, you can see how much method, how much rational we have to be. However, in some cases, if all the things are fulfilled, in case of independent t-test, only there is some homogeneity of variance is not fulfilled, still you can apply the independent t-test, but the reporting will be different. That I'll tell you once we will be doing the independent t-test. Just to give you one overview that how measurements affect the final outcome of your data, the final outcome of your analysis. I have been talking about this. So whenever you arrive at a statistical test, please make a decision tree. Be very clear on how you arrived at that test rather than applying your whims and fancies or somebody is using that. That's why, because I have seen many people, I'm talking almost 4 or 5 years back, uh, they wanted to apply structural equation modeling. And I asked, why you want to apply structural equation modeling? Because everybody is applying. Everybody is applying doesn't make sense for you to also to apply. You see that whether your data, whether you have the constructs of that kind, whether you have some observed constructs, whether you have some latent constructs or not. If you don't have, why you are applying some? A simple regression will do that. Why to trying to kill an ant with a sledgehammer? Yes, don't be into that. So now basically there are three things. Independent sample I have already talked about. Dependent sample I have talked about. Then there are replicates. Right? Here I'll take the case of uh, rat. Let's say I have taken two rats. One is weighing 15 kg, another one is weighing 5 kg. And to the 15 kg rat, what I did, I put that rat on a strict diet. And over a period of time, I want to check that what is the effect of diet on its weight. So let's say after a week, I tested the weight. And I found that when put on the strict diet, the weight decreased to, let's say, 1 or 2 kgs. But after a month on a strict diet, the weight decreased from 15 kg to 10 kg. So from here, I'm finding out the effect of diet on weight. And it shows a significant change, and this relationship can be measured where the weight becomes dependent on the diet. So diet is the independent variable and weight is the dependent variable. But suppose if I'm taking the weight of the same rat on a daily basis, so first day 15 kg, second day it went to 15.1 kg, third day it went to 14.9 kg, then again 15 kg, 14.95 kg. See, when I'm measuring this on a daily basis, what is happening? There is a very slight change in the weight. Though there is a change, but very slight change, which is not statistically significant. This situation is known as a replicate, and we should try to avoid measuring replicates when we are going for dependent and independent variables. So your measurement should not be at so small intervals that the dependent variable, the effect, cannot be measured effectively, or the change that is happening or the effect that you want to measure is so small in magnitude that it bears no statistical significance. Then that situation is replicates. And whenever we do measurements, please try to avoid these replicates. Then now coming to the main thing. After measurement, deciding on your variable, the next thing is a normal distribution. Whether your data is following a normal distribution or not, whether it is normally distributed or not. So this can be tested. And I already told you that this is the bell-shaped curve. It ranges from mu minus 3 sigma, mean minus 3 standard deviation to mean plus 3 standard deviation. Whatever lies between the mean minus, just hold on. Uh, Before I start telling about uh, how to measure this, is there anyone in the house who wants me to tell how to create variable and enter data into a spaces? I hope you all are aware of this, or anybody who wants me to explain that step. Anybody in the house?
Yes, sir. Please explain, sir.
Yes,
Okay,
sir, explain that, please.
Yes, sir.
okay,
Kindly explain.
sure. Not a problem. I'll do that. Just a minute. Let me open my SPSS. Take some time to open. Okay, so here it is. Is it visible? Is this visible?
Yes, sir.
Yes, sir.
So see, here we have two things, a data view and a variable view. So in variable view, we create our variables. So I'll just take example of a questionnaire and then we create the variable for you. So already this questionnaire, I think I have shared with you people. Let's say this is the questionnaire. So it is a statistics anxiety questionnaire or SPSS anxiety questionnaire consisting of 23 questions, which I have used to measure why people they are anxious about using SPSS. So similarly, you might be doing some study, you have your dependent variable, independent variable, and to measure that, you have a question and a scale. People might be taking 1, 2, 3, 4, or in a Google form, they might be taking all these things. Now, how to enter all this into SPSS? For that, we have a variable view. First, we have to create these things in the SPSS, and then we have to enter the data through data view. So first is the name. So let's say this name has nothing to do with your statistical calculation. It is for the identification. Let's say if I want to put the all responses that people have given on question number one here, so I'll just put question number one, right? Automatically, this will the type will be numeric. Now I have to decide whether it's numeric or what. So if I have taken this data on a scale, let's say strongly disagree to strongly agree, and I have coded it like 1 is equal to strongly disagree, 2 is equal to strongly agree, 3 is equal to neutral, something like that, then that is in numbers. So I'll keep it numeric. By default, the width is 8. That means that the number of characters that you can use in your input can be 8. If it is more than that, you can increase it. How many decimal places of data you want. By default, it will be 2. You can increase or decrease it depending on the kind of data you are taking. So let's say in my questionnaire, it's 1, 2, 3, 4, 5, no decimal places. So I'll keep it 0. Now here comes the label. Now the label is the here whatever you will type that will get printed on your output. So normally in the label, we put question as it is. So if I have to compute how many people have responded to this question, so it will print also and it will help me. So simply copy and paste, nothing else. Now coming to the values, this is of prime importance. Here you need to tell the software that what do you mean by this 1, 2, 3, 4, 5. Here in your questionnaire, you know that 1 means strongly disagree, 2 means disagree, 3 means neutral, and so on. But the software does not know. And if it does not know, what will happen? It's just a software. You will give some numbers and it will give you some numbers in return, which won't make sense. So you have to tell this software what do you mean? What do you mean to say by 1? So here you have to click, put 1, and let's say 1 is strongly disagree. Or in short, I will type SD. Then 2, disagree. 3, neutral. 4, agree. 5, strongly agree. Suppose if you have mistyped something as mistake, like 3 should be agree and you have typed neutral, let's say. So you can click here, remove, or by changing here, you can click on change also. So here you can do this. So sorry, 1 is equal to strongly disagree, 2 is equal to disagree, is equal to neutral, 4 is equal to agree, 5 is equal to only agree, add, click OK. And you can see it has come. Whenever the next time you click here, you can see it is there. We don't want any missing values, so keep it default miss as it is. Here also default alignment has nothing to do with it, only it will tell you when you will input the numbers, whether it will be right aligned, left aligned, or center aligned. That has nothing to do with your statistics. Now the measure, whether it is nominal, ordinal, that is categorical, or scaled, that is, if it is ratio or interval, it will fall into the category of scale. If it is nominal, let's say gender, roll number, something like that, then it's nominal, or age group, income group, then it will be nominal. Otherwise, it will be ordinal. And if it is interval or ratio, then scale. So if you see, these questions are taken on a 5-point Likert scale, and I already told you that in the basic form, Likert scale is ordinal. Only rank is there, so we will put here ordinal. Then similarly, we will create question number 2. The moment you click here, it will be this. We don't want any decimal values. And our second question is, my friends will think I'm not able to cope up with this pieces. I'll put this label here. Now, again, I have to put the values. Now, please remember one thing, that if the scale is the same throughout, if you are using the same scale, means 1 means strongly disagree, 2 means disagree, 3 means neutral and all, you need not to create it again. Simply copy this and paste here. That's it. And if you click, the same thing has been pasted. No need to re-enter again unless your scale is changed. Again, it will be ordinal. And now if you see in the data view, you can see your question 1 and question 2 created. Now this will be your variable horizontally, and vertically you will be your response. So respondent number 1 response on question 1, respondent number 2 response on question 2, where they are giving responses as 1, 2, 3, 4, 5. So similar. So if you hover on this, you'll find whatever you have typed in label. So you can very well identify that question number 1 is about statistics makes me cry statement. Question 2 is, my friends will think I am stupid for not being able to cope with SPSS. So like this, you will create the variable. And if I show you the full variable and the data, so once we have created this and taken the responses from the questionnaire, you will enter all the responses. So you can see it is what we have created. Say question 1, 2, 3, 4, 5, 23, all these values and all, and you can see the responses. So already we have the responses of the people also. So we have collected the responses of 2,571 people on all questions, and you can see that we have all these responses. Right? So this is how we create the variables and we input the data. Is this step clear?
So can you please repeat the last step, like how you transfer data?
Okay, how I opened this data?
Yes. Yes, sir.
Okay. So see, SPSS supports Excel file as well as its own file, .sav. See, there are two kinds of SPSS file, .sav, which is the data file. And when you create an output and save that output, then it is stored in the form of .spv, SPSS viewer. So it supports both the file. If your file is in the form of data file, simply go file, open, select data, and the SAV file where you have saved, it will be created. It will be there. If already you have created. If not, then like I have told you that variable view you will create. Then in data view you will enter all this data and you can simply save it, save as, and by default it will be a save file. So already if it is a saved file, then you can go click open data and save. If it is an Excel file, then from here you have to click dot xlx, and then you have to select that Excel file, open.
Excuse me, sir. Can we directly copy paste from Excel to SPSS?
You can do that also, but see, suppose if it's a huge data, then it could be a problem for you while copying and pasting, isn't it? You
Yes,
can
sir.
you can do a copy paste, not a problem. But if it's a huge data, it will of course create a problem. So now it is asking you that whether you want to import the entire sheet. Yes. So you can do like that also. And if you are importing in Excel, what will happen that your variables that you have created in Excel, that also gets ported, that also gets imported. Otherwise, copy paste, in that you have to create the variable, then you have to select the entire row and the column, copy and paste that Excel. So why to go for that tedious task when it allows you to import the Excel file? So you can open SPSS file or the Excel file like this. Am I clear on this?
Yes, sir.
Sir, there is one doubt.
Yes, please.
Sir, in this particular scale that you have used for demonstration, like for this particular scale, we need to choose scale formatting measures or ordinal, like you have chosen.
See here, you will be presented with three options: scale, ordinal, and nominal, right?
Yes,
Okay.
sir.
So if your measurement, the scale that you have used is either interval or ratio scale, then you will select the scale, okay, which means metric
Okay.
scale. If it
Okay,
is
sir.
if it is nominal in nature, like gender, if you have taken, name you have taken, or age category, or let's say income category, then it will be nominal. If it is rank ordered, then ordinal. And already I have told you that Likert scale in its basic form, where it is ranging from strongly disagree to strongly agree, that is ordinal in nature because we have used this scale if you see. So that's why we have chosen here ordinal. Okay.
Okay, sir. Thank you.
Most often with the latest version of SPSS, if you have the data, based on the nature of the data, SPSS by itself selects what kind of scale it is. But you have to cross check whether it has comprehended your scale correctly or not. Okay.
Okay, sir.
Yeah.
Sir, hello.
Yes. Yes, please.
Sir, we can do the like in when we are converting the questionnaire and importing the data from Excel to this, we have also the demographic data.
Yes. Yes.
Put it in the same sheet, isn't it?
Yes. 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 So
In the
just
tables.
let me tell me one demographic data.
Like we have initial questionnaire has demographic data, no? Like
Yeah.
their gender, their
Let's
income category.
let's say my question number 3 is on gender. So you can put here gender.
Yes.
See here you have to code gender.
Yes.
Gender will be male or female. So let's
Yes.
say 1 stands for male and 2 stands for female. Okay. Again, it is nominal in nature. Now you go to your data, you view this question 3 is about gender. Here you will not type male, female. Here you will type 1, 2, 3. Is that clear? Sorry, 1, 2, 1, 2,
Yes, sir. Yes, it is
as
clear.
you have coded. Okay. If you want to see the difference, let's say if I have put 1, 1, 2, something like that, 1. Suppose if I want to see what does this 1 and 2 means, I can go to this coding, or here you can, are you seeing this? You can click on this. It will put its label value here. You can click here and always you can change and see that what does 1 means, what does 2 means. Is that clear?
Yes, sir. Thank you.
But for that, proper coding needs to be entered here. Okay. This is how we create the variable. Is that clear?
Yes, sir.
Okay. Now, once you have entered the data, let's go on to the data cleaning. Anybody who is not clear on this part? I hope everybody is clear. Now, this is a huge voluminous data. 2,500 samples, 23 questions. See, first thing, we need to clean the data. For data cleaning, we find out for a data to be cleaned, there should be no missing values. If there are missing values, and impute those missing values. No outliers. There should not be outliers. This we identify through box plots. Now, missing values are those values, let's say you have handed your questionnaire to the respondent. And might be the case that on a particular question a respondent has not responded. And now you have 1,000 questions in your hand and you are inputting all those data in this SPSS. Now you found that 10 people have not responded to a few different questions. You can't afford to go back to those 10 people and ask them to fill it because the data has been uh, taken over a period of time. You can't afford to go back. Now, nowadays, but this will happen when you are using a printed questionnaire. Nowadays, most of the people, they are using Google Forms. And suppose if you have made a form field mandatory, then people have to fill. Then there won't be chances of missing values. But suppose if it's an open-ended question, let's say, what's your age? Rather than category, either you can ask what is your age category, where one is 20 to 25, two is 26 to 30, something like that, then people can click on it. Suppose if you have asked open, made the form field mandatory. So missing values won't be there, of course, people, because they have to fill, it's mandatory, otherwise the form won't get submitted. But suppose if your respondents are mostly 20, 21, 22, something like this age, and somebody is of the age of 70, they will become the outlier. So by the nature of different kind of populations, by mistake, this might happen that you have a missing value. It also might happen that you have an outlier. So missing values are those values which either you failed to enter into your data sheet or the respondent field. However, this is now being taken care of by using Google Forms. But even still, if by some chance there is a missing value, it will have an impact on your overall mean value. Because let's say you have 10 respondents and you want to calculate the height of 10 respondents. 2 have not responded. I'm just giving you a small brief. Out of 10, you can easily identify, but out of 1,000, you cannot identify. I'm just giving you an example to understand where the problem is. 2 have not responded. But when you will calculate the mean age, you will summate all the ages and then divide it by 10, where there will be two values which will be 0, 0. So finally, it will have an overall impact on your mean value. This will be the problem posed by the missing value. Second problem is, let's say if you have taken a open-ended question, let's say you have asked age. I'm just giving one example. Age, you could means it could apply to any kind of data. So most of our respondents are belonging to the age 20 to 25, but somebody is belonging to 60. Then again it will impact the mean. Somebody is belonging to the age category 15 only. Again, on the lower side, it will decrease the mean. Ultimately, it will end up in error. And most of these statistical calculations are based on mean and standard deviations. So these two value things, missing values and outliers, needs to be taken care of while cleaning the data. Is that clear? Is this concept clear?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
now in a big data set, how to identify this missing value and how to impute it? First thing. So you can go to analyze and simply click on descriptive statistics. And here you will find the option of frequencies. Okay. You will be presented with this. Whatever statistics you choose in IBM SPSS, you will get this box. So this is the list of your variables, but there won't be any statistical calculation won't be applied to them unless you move them into this box. So if you have some selective variables, you can move them. Let's say question number 1, 4, something like that. Or multiple, you can select by clicking on one, holding the control button and selecting others and then putting them here. And if you have to select all, then press Control plus A, because here we want to see the missing values in all the cases, and click here. And nothing you have to do, simply click OK. It will give you this table and it will tell you that whether there is a missing value or not. So if you see question number 1, no missing value, question number 2, no missing value, 3, no missing value, 4th, there are 2 missing values. So now you have to focus only on question number 4th. So if you see question number 4th, find this is one missing value, and here also there is a missing value. Means respondent number 15 has not responded, or might be they have responded, we failed to enter. And if it's a printed questionnaire, again finding the respondent number 15 from a pile of 1,000 questionnaires is a help, and then going to that question again a Herculean task. And suppose what if they have not responded, then going back to them, that doesn't make sense. So what we need to do in this case, we can impute this by taking the mean of the preceding value and the succeeding value. This could be one method. Another method, let's say, in a row, respondent number 15, 16, 17 has not responded on this question. Then preceding and succeeding values will be too far. Then in that case, you can use both ways. When you have calculated this, you can see you can do one thing while selecting this. See, if you want to impute them by taking the mean of the preceding and succeeding values, then 2 plus 2, 4 by 2 is equal to 2. You can impute this by 2. Or in the same process, descriptive statistics frequencies, which we have done, you can select a mean value. And it will give you the mean value of the same table. Along with the mean value. So either you can take the preceding and succeeding mean, or you can and impute it, or you can take this mean value. So 2.79. Since our scale is 1, 2, 3, 4, 5, so you have to take the nearest decimal. So it will be 3. Or you can take the preceding value and the succeeding value and impute it. So you can do either of the.
Yeah,
Yes.
so which means one is, as you said, preceding and succeeding values and the mean. But
Hmm.
the second method which which you're explaining, is that
Hmm.
you take the entire question's, responses mean, right? And
Yeah,
that
yeah.
you take as a missing value,
Hmm.
right? That is what you have to consider. So, and, mean value for that particular missing.
Yeah,
One.
yeah. So what I'm saying, either you can impute it with the preceding and succeeding mean values or the overall mean values.
So what is the difference then in terms of implications of the overall mean value?
Sir, they won't have any implication. You can choose either of these method, what I'm trying to say.
Okay, okay.
See, suppose here there is a preceding and succeeding mean values.
That's
Let's say this respondent has also not responded, this respondent has. Now, which one will be the preceding and succeeding? Can you take
right.
all? Huh?
No, no, no.
Then in that case it would be better that you take the overall mean,
Correct, correct, correct.
right, sir? So for that matter we are doing this.
That's good. Thank you.
Okay. And actually it won't be the correct value. Might be this respondent might have responded something else. But
That's
what this imputation will help? This imputation will help at least to bring your values closer to the actual mean.
Yeah.
It could not be the exact value, but it could bring it closer to the actual mean, right?
That's right. At least loading is better than no loading.
Yeah.
That's right. Thank you.
So this 2 and 3 plus 1, 4 by 2, like this. Similarly, let's say you can see other questions. Again, in question number 1, 2, 3, 4, 5, 5. In fifth, there is one missing value. So if you see fifth, there is one missing value, and where it is. If it is in Excel, then you can easily do this by filtering. But if your data is in SPSS, then you have to find out your missing value. And yes, it is somewhere here. It was. Yeah, here 3 plus 1, 4. Then again 2. So like this, you will impute and clean your data. Now, second thing is the outliers. The extreme values are in the means those values which are beyond your range. So our range was 1 to 5. Strongly disagree, 2 strongly agree. Something much below this 1 and something much beyond the 5 will be the outlier that will affect our overall. Now these outliers might be due to you have given an open-ended question. And if you have given a closed-ended question, then the respondent has to tick something between 1 and 5 only. They can't go beyond that. But what they have given 5, but by mistake while typing, because it's a hell lot of data, you have typed 15. Somewhere you have typed 50. How will you identify it? And suppose if it's an open-ended question, then respondents are free to give any response, any number. What if this is the case? How will you manage such data? So first thing is to identify the outliers, because outliers will be affecting your entire mean. Imputation will be the same. Take the preceding and the succeeding value and their mean, but first you need to identify. This is identified by box plots. So simply you go to analyze, descriptive statistics, explore. And here in the dependent list, you have to select all your variables. Select on statistics, and here you will be getting the option of outliers. Click on continue. Okay. Now just see your output.
Sir, can you please repeat this step, sir?
Okay. So the step is go to analyze, descriptive statistics, explore, select all your questions in the dependent list, click on statistics. Here you will be getting the option of outliers. Click it, click on continue. Okay.
Sir.
Now scroll down, and you will get these box plots. Wherever there will be outliers, it will be marked with asterisk. See, this is known as the quartile 1. This is known as the quartile 3. And in some cases, you will find there is a line between this. This is known as the median. Okay. So the box plot is nothing but a representation of median, and it also shows you the lower limit. This is the lower limit and this is the upper limit. So these were responses. This is question number 1. Statistics makes me cry. Respondent number 2491251023782471. They have given high values like 5, but it's not outlier. They have given somewhere 5 only. So if there is outlier, it will be marked with asterisk. So please see question one by one. First question, no outlier. Second question, no outlier. Third question, can you see? Respondent number 253 marked as asterisk. Can you see this?
Yes, sir.
Yes,
So
sir.
it is an outlier. Now let's go back. Question number 3, respondent number 253. Question number 3, respondent number 253. See, why it is an outlier? Because he has given 10, or by mistake I have typed 10. That's why it is being marked as outlier. And it will have an effect on overall mean. So what I have to do? The preceding value 2, succeeding value 4, 6 by 2, 3. I have to impute it by 3. Now it is in the range. Now again, get going. No outlier. No outlier over here. No outlier over here. No outliers. No. No. Yes, this question. Computers are useful for playing games. 301, an outlier. Which question this was? Yeah, this question number 10. And it was respondent number 301. So coming to 301. Yes, why it's a outlier? Because might be the respondent has responded 4, but I have mistyped, or the respondent, if it's open-ended, has given 14. How to impute it? The preceding succeeding value 3 plus 1 4 divided by 2. So it will come to it. So like this, you will clean your data for missing values and for outliers. Number 1. Second thing is, suppose if you have to do any analysis repetitively. So every time you need not to go to analyze. Whatever you have recently done will be shown here. This is known as the recall box. So if you click on this, it will tell you what we have done: explore, frequency, reliability. Already for some other analysis I've done. Just now I have done explore and frequency. So if I have to do again this, simply I need not to go to analyze, then descriptive statistics, then explore. Simply I can go to this explore, and it will present me with this dialog box. Frequency I have done. If I click frequency, the same thing. I need not to go to the entire process. Just as a shortcut, I can select from here. It will give you the list of latest analysis that you have done. So from this recall box, you can use it. Is that clear?
Yes, sir.
Yes, sir.
Now,
Sir, there is one question.
yes, please.
Sir, like for how many missing values we can replace the missing value with the
Yeah.
mean value of the old?
See, if the same respondent, okay,
Yes, sir.
has given you more than three missing values, right? Then you discard that respondent. I mean, let's say if respondent number 305 has given us more than three missing values missed on three different questions, then I need to discard this respondent. If more than three outliers, then also. If every respondent or number of respondent has given on a single or two missing values, then you need to replace. There is no limit for it. But one single respondent giving you more than three outliers or three missing values, it's better to discard that respondent. Delete their entire this, unless it is not affecting your overall sample size. If you have fairly large enough sample size, deleting a few respondent won't affect your results much, right?
Yes, sir. Thank you, sir.
Yeah. And please remember that the minimum sample size that is required to generalize the study is 384 if your population is infinite and you are taking a probability sampling. If you are taking a non-probability sampling, then we take a ratio of item is to means question, that is known as item is to sample 1:5. So for one item, there should be minimum 5 responses. So let's say if you have 20 questions in your questionnaire, minimum 100 responses should be there. That is applicable when you are doing non-probability sampling. When you are doing probability sampling, then minimum sample size should be 384 in case of finite population, in case of in case of infinite population. And if it's a finite population, then we apply Cochrane's formula or Yamane's formula, which I'll be telling you when we'll be discussing about exploratory factor analysis, and there we will be talking about sample size, adequate sample size. Okay.
So please repeat this point.
Which
Probability
one?
probability sample. If I'm taking, then what is the sample size?
See, if you are taking a probability sampling, okay, and your population is infinite, means it's a very large population, right? Then minimum sample size required is 384. Okay.
Yes,
If
yes.
if your population is finite, means you can measure your population, then you use Yamane's formula. There is a Cochrane's formula also, but it's a little bit tricky. This one is easy. N is equal to, I said I will be discussing on this when I'll be discussing about sample size adequacy in this one, exploratory factor analysis. So it is small n is equal to capital N upon 1 plus NE square, where capital N is the size of the population because you know your population size is finite. So you know this, and then you can, E is the error estimate, which is normally 0.05. Put this into formula, and that will be your sample size. This is applicable to probability sampling. For non-probability sampling, we take item is to responses ratio. It is always 1:5. This is known as KMO method, Kessler-Meyer-Olkin method. For one question, you need to have minimum 5 responses if you are applying non-probability sampling. Is that clear?
Yes, sir.
Okay. Now, so one recall box I have told you. Now, second thing. Let's say after entering my data, I came to know that I have wrongly coded my questions. What needs to be 1 has to be 5. Means my scale is in reverse order. I have done reverse scaling, but here I have wrongly put all this. So means what happens to be, let's say, see this scale. So what I meant as strongly disagree. One, here I mean I'm reverse coding and I mean that one should be strongly agree, two should be agree, three neutral will be as it is, four should be strongly, four should be disagree and five should be strongly disagree, completely reverse. But here I have taken it as one is equal to agree, two is equal to, one is equal to strongly disagree, two is equal to disagree. Now how to correct this? Are you getting the problem?
Yes, sir.
Yes, sir.
Yes, sir.
One, reverse code it. So one option is find and replace all four to two, all three to three will be three, all one to five, all five to one, isn't it? That is one option. But for such large sample, how you can do it? So here there is something that helps you. So this is known as, there is an option record into same variable. You also have an option of record into different variable. Record into same variable will record in the same variable. Record into different variable will retain this, and recorded options will be created as a new variable. So I will tell you both. So record into same variable. So first let's do record into different variables. So let's say question number one, I want to record. I want to change all four to two, all one to five, and all five to one. And three is the neutral point, so it will remain as it is. So go to transform, record into different variables. Let's say this question only, first one. And I have to create one new, let's say question one, because it's record into different variable. And I'm putting R, so recorded. So just for label, I'm putting recorded. Now click on old and new values. So I want one to be 5, two to be 4, 3 will be 3 only, 4 will be 2, and 5 will be 1. So I've done this reverse coding. Continue. Yes, I don't need change. Okay. Now if you see, actually it will go in the last. And you can see that question one, and here I will remove the decimal values to 0. I will keep it. So it will retain the original value and it will create a new variable with recorded value. You can see all 4 has become 2, 3 will be 3, all 2 has become 4. Now it is recorded. So if you want to keep the original value, and if I just for comparison purpose and want a recorded value as a new variable, you can create that also, or you can replace this completely by recording into same variable. So transform, record into same variable, the same method, question one, old and new values. There I have just created a new variable so that I could see that means my original value does not get disturbed. So all 1 to 5, all 2 to 4, all 3 I'm leaving it, all 4 to 2, and all 5 to 1. Continue. Okay. If you could see, this change has happened in the same variable. If I want to keep it and create a new variable with the recorded values, then I can choose record into different variable. Yes, I can, else I can choose record into same variable. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now, this is a data cleaning method that I have done. Let me show one new data and explain you something new. Now, let's say here I have a data, and here I have asked students about their, or people about their ages. So 20, 22, 24, 31, something like that. Later on, I decided that I want age category rather than the absolute age 20, 21, 22. I want to put them into categories. Like 20 to 25 should belong to category 1. 26 to 30 should belong to category 2. I want it like this. So one way is that I go to 20, convert it into 1, 22 convert it into 1, 24 convert it into 2, 31 convert it into 2. So like this, I convert each and every value. Rather than doing that, I can use the same transform, and I can, let's select record into different variables, and this age I wanted. So let's say age, I will put it C category, age category, just for my identification purpose. Now old and new values, where what I will do, I will put here range. But before that, I want to know what is the range, from where it is starting and from where it is ending. So analyze descriptive statistics, frequencies, age. In statistics, I will select minimum and maximum. Okay. So it is starting from 20, ending at 25. So let's say I want to put age category with a class interval of 5. So 20 to 25 will be my category. 26 to 30 will be my category 2. 31 to 35 will be my category 3. 36 to 40 will be my category 4. 41 to 45 will be my category 5. And 46 to 49 will be my category 6. So what I want to do with the existing data, where all values are given, the ages are given in absolute number. Similarly, you can do with income or anything, where you want to have a discrete data into classified data, into class intervals. So go to transform, and you can choose either record into same variable, so it will convert all these, or record into different variables so that you can see what was your original value and what you have done to what new value you have created. So it's better always to record into different variable. So age, so age underscore C, that means category. For my identification, age category. And old and new values here, rather than selecting all this, I will select a range, and I will say that from 20 to 25 I want to put as 1, right? 26 to 30 I want to put it as category 2. 31 to 35 I want to put as category 3. 36 to 40 I want to put as category 4. 41 to 45 I want to put as category 5, and 46 to 49 I want to put as category 6. Continue. Inch. Okay. Now, if you go to the data, can you see this? In variable, you just put this to 0. Can you see? Whatever we have defined as this category, now rather than this, we have got their categories.
Yes.
Yes, sir.
Okay. So this kind of transformation also you can do through this recording. Now another thing that you can do with SPSS or Excel or both. Let's say this is a list of 361 respondents, right? I want to choose randomly from these 361 because you might be knowing for simple random sampling method, which is one of the best method of sampling. See, if you already have a sample frame or the list, please try to do the probability sampling, which is simple random cluster stratified. I don't know why people do. Suppose you are doing study on the students, your respondents are the students of your own university. Why you are going for a convenience sampling? You can have their list and randomize it, right? And there is also a very wrong notion about random sampling. You went to a marketplace, you want to know the attitude and perception of consumers. You went to a marketplace, a shopping mall, and you met people randomly. You asked them to fill the questionnaire, and then you are saying it's a random sampling. No, it's not a random sampling. The random sampling is a very scientific method. Meeting people randomly and handing them the questionnaire is not a random sampling. That's again a proximity sampling or convenience sampling. It's non-probability sampling. Random sampling is a very scientific method, or probability sampling is a very scientific method. First thing is that you cannot decide the sample size by yourself. You have to decide the sample size based on formula. So now you can see here that we already have this. Let me open this Excel file for this. So I'll tell you how to do it in Excel as well as I'll tell you how to do in SPSS also. So this was the data. Now, if you see, I have 361 respondents. I'm sorry, 361 is my sample frame. So that is my population size from a particular, let's say, B school. And I want to select some random samples. So how many? First thing, what should be my sample size? So since it's a finite population, so I will choose Giamne's formula. Is equal to n by 1 plus n e. It will translate to capital N is 361 upon 1 plus 61 1 plus 361 into 0.05 because we take confidence level at 95% and margin of error at 5%, which will translate to 0.05. So 0.05 square will be 0.0025. So into 0.0025. To calculate this, it will come out to be 361 upon 361 into 0.0025. Let me calculate it. 361 into 0.0025. It will be 0.9, and 1 plus 0.9 will be 1.9 equal to, so 361 divided by 1.9 is equal to 190. So 190 will be my sample size. So out of these 361, I have to choose any 190. So one method could be that I made, that's why it's known as lottery method. I prepare a slip off all these 361, put it in a box, and pick 190. Again, it's a very hard demo task. Let the software do it for us. So here in Excel, what you can do is equal to, you can apply rand function. What it will do, it will give a random number to them, and then drag and drop. Right? So randomly it has assigned a number, and then sort and filter. Let's say from smallest to largest. Expand the selection sort. Now you can see all have been arranged randomly. Pick this starting 190, and they will be your random samples. And you have to give the questionnaire to the students having these roll numbers.
So please repeat this last method of giving numbers in the here.
Okay. So what you can do, you can apply is equal to rand function. Okay. Hit enter. It will assign the random values. Drag and drop it. Okay. And then from here, sort and filter, sort smallest to largest. It will give you the option expand the selection sort. And you can see that it has arranged them randomly. Pick any 190 from the starting. All will be random. And for every person, this arrangement will be different because it is being arranged randomly. Is that clear?
Yes, sir. Yes, sir.
So
Thank you.
only to first 190 people whose roll number is appearing here, I will hand over my questionnaire. They are my sample. If you want to do the same in SPSS, how you can do? Go to this transform. Here's random number generators. Again, I repeat, transform random number generators, and from here click set active generator. You can choose any of the options because both are random number generators. Both work the same way with a little bit of difference. So SPSS 12 compatible or machine twister, it's up to you. Click OK. Random number generator set. Now go to data. From here, select cases, and based on this serial number, this we are taking randomly. Select a random sample of cases. Sample. So if you want to take percentage wise, then percentage wise, but here we have absolute numbers 190. So exactly 190 from 361 cases. 361 cases. Continue. Okay. You can see randomly few have been not selected and few have been selected. Those which have been this crossed, they are not selected in the computation. So if you want to check that, go to descriptive frequencies. Even if you see the age, how much is the total? So if you want to see how many have been selected, so you can find only 190 are valid. Rest have been discarded and they have been selected randomly. But this might seem to be somewhat messy. Finding out, copying them, pasting them. So let the software do it for you. So what you can do first, you have to remove all this. Select cases, all cases, remove this selection of filter. So go to transform random number generators, it is there, and transform, sorry, data, select cases, the same thing, random 190 to 361 cases. Only change that you have to do is copy selected cases to a new data set. All those 190 to a new, let's say ABC. Okay. Now you can see there will be new files generated ABC, and it will contain 190 randomly selected cases. So this is how you can do it. So this is data cleaning, coding, transformation, selecting random cases. Now coming to checking of normality, which is important. So once you are done with cleaning and coding, now you have to check whether your data is following the normal distribution or not.
So,
Yes, please.
so when we are applying this random number generator and getting 190 cases, then all others will be removed from that data set.
Means they will be remaining in the data set, but they won't be computed while doing any computation.
Okay, okay,
They won't be selected in any computation.
okay, okay.
They will remain there, so that in your master file they will remain, but
Yes.
since they have been striked off, so they won't be, whenever you do any analysis, only those 190 will be included in the analysis, others will be removed.
Okay,
Means will not be included in the analysis.
okay, okay. Thank you, sir.
Now coming to the normal distribution, which is important. See, if a data is categorical, it won't follow normal distribution, but if it is continuous, chances are that it may follow normal distribution. And for applying t-test, for applying ANOVA, for applying Pearson correlation particularly, your data should follow normality. And even in case of regression, not the data but the residual errors should be following normality. So I have seen many people applying all these tests, ANOVA and all, without focusing on whether their data follows the normality or not. And normal distribution, as I have already explained, it is a bell-shaped curve. So ranges from mu minus 3 standard deviation to mu plus 3 standard deviation. The range between the mu minus 2 standard deviation to mu minus 3, mu minus 2 standard deviation to mu plus 2 standard deviation is known as the confidence interval, which is generally kept at 95%. The remaining 5%, which ranges between mu minus 3 sigma and mu plus 3 sigma, means mu minus 3 sigma to mu minus 2 sigma and mu plus 3 sigma to mu plus 2 sigma. That is known as the error zone, and it is kept at 5%. And this normal distribution lays the foundation for hypothesis testing. We say that if p is less than 0.05, reject null hypothesis. From where it is coming? It is coming from this concept only. So if p is less than 0.05, that means that it will fall into your confidence interval, and hence you should reject your null hypothesis. If p is greater than 0.05, then it will fall into the error zone, and you have to accept the null. Means you fail to reject the null hypothesis. So we'll be coming to that later on, but first know how to check the normality. Tomorrow we'll be testing, when we'll be doing independent t-test, the homoscedasticity or homogeneity of variance. That is also known as homoscedasticity. But first, normality of data. There are two statistical methods and two graphical methods. So statistical methods is one sample, KS, or no grow, no method. And one is Shapiro-Wilk method. Graphical method is program and normal T probability or normal quantile These are for univariate normality. Univariate normality means when you have only one dependent variable, means that is the univariate statistics. When you have more than one dependent variable, independent variable can be many, but if you have more than one dependent variable, then that becomes the case of multivariate test. And in that case, we test multivariate normality. These are for multivariate, univariate normality, means one dependent variable and you are checking the normality. For multivariate normality, you have Anderson-Darling test. It is not available in SPSS. It can be done in R or Python. But graphical method you have, that is this normal PP plot and normal QQ plot for multivariate normality also you can do. When we'll be doing regression, I'll tell you. As of now, focus on this. Now, there are two methods. Shapiro-Wilk method is more powerful than one sample KS. But only limitation with Shapiro-Wilk is that if it is applied on a large sample size, sometimes it gives error. So if your sample size is more than 100, then please try to apply Kolmogorov-Smirnov. Otherwise, Shapiro-Wilk is the best method. It's very strong. It is powerful than Kolmogorov-Smirnov, but fails to render accurate results at large sample sizes. So at large sample sizes, you can apply Kolmogorov-Smirnov, otherwise Shapiro-Wilk. Graphical method is just for, means if you want to cross-validate, and for this assumption, normality assumption, or any of the assumptions, normality assumption coming to be true, P value should be non-significant. That is, P should be greater than 0.05, not less, greater than. Because here, when we test the assumption, the null hypothesis is the assumption is fulfilled. If we are going for normality, then the null hypothesis is test data. The data that we are testing, data is normal. So if we want to, if P is greater than 0.05, that is non-significant, then only you can accept this null hypothesis. Otherwise, you have to reject. So either this way or this way, P should be greater than 0.05. Now let's test it on a real data. So file, open, data. There is an Excel file. I have shared with you people all the data sets that will be used throughout the sessions. Normal distribution. Okay. So this data is about the protein present in 1 picogram ml of blood. So you can see this data, this is the protein in 1 picogram ml of blood. So we want to test the, we have taken the samples of blood and we have taken this serum protein present in it, and we want to see, you can see that this is the ratio data, because already I have told normality cannot be applied on categorical data. It can be applied on continuous data. So either your data should be interval or ratio, and ratio measurement is the highest level of measurement. So this is ratio measurement, and it is for 64 samples. So it's a very small sample size. So what I can do, I can go with Shapiro-Wilk. However, in SPSS, when you compute Shapiro-Wilk, it also gives you one graphical method also, and side by side it gives you Kolmogorov-Smirnov also. So go to analyze. Descriptive statistics explore. This is of very importance because this explore, the name itself is explanatory that you can explore a lot of things through this on the data. So this you have selected in the dependent, and in the plots, select normality plot with test. Continue. Okay. So you can see this table. As of now, forget about Kolmogorov-Smirnov because when you do this, it gives you also Kolmogorov-Smirnov statistic. So even if you see the Kolmogorov-Smirnov significant is level is 0.200, which is greater than 0.05. So test distribution is normal. Since sample size is small, so we will focus on Shapiro-Wilk. It is coming to be 0.581, which is again greater than 0.05. So test distribution is normal. Our data is normally distributed. It also gives you a graphical method, normal QQ, quantile plots. So if you see how you will infer this, if these data points are very close to this diagonal line, most of the data points, and are in symmetry, you see the upper this arrangement and this lower arrangement is more or less symmetrical, then we say that the data is normally distributed. So this is one method. So you have got a Shapiro-Wilk method and one graphical method, that is the normal KQ plots. So you can cross-verify through this and then match with this, or you can just to show that the visualization of this in the form of this, you can also select the normal KQ plot. Suppose if you have a large sample size, then you will take into account this KS, or you can stand-alone do KS test by selecting analyze non-parametric test, legacy dialogues, one sample KS, only stand-alone. Select this. By default here normal is written. Okay. Okay. And see, the same p-value is 0.200, greater than 0.05. So test distribution is normal. Here also it is written test distribution is normal. That doesn't mean that it is telling you the result. It is a null hypothesis created by this. So even if this value is less than 0.05, then also it is written test distribution is normal. Please remember that SPSS does not give you inference of the result. So this is only the null hypothesis. So if this is the null hypothesis, if P is less than 0.05, it will stand rejected. P is greater than 0.05, you cannot reject, you have to accept this. So in that case, you can say since P is greater than 0.05, so null hypothesis cannot be rejected and test distribution is normal. Is that clear?
Sir, what
Yes.
is how much will be large sample or small sample?
What I'm saying, if your sample is more than 100, then applies Kolmogorov-Smirnov. If it is 100, up to 100, you can apply Shapiro-Wilk. Okay.
And for large sample, please repeat how you have done this normality test for large sample.
See, I have taken the same sample. You can do standalone Kolmogorov-Smirnov, analyze, go to non-parametric test, legacy dialog, one sample KS. That's it. Select your variable, click on OK. Right? This is giving you one sample Kolmogorov-Smirnov. Okay.
Okay, sir.
And please remember that this first point is not the inference. Okay. It is only the null hypothesis. SPSS never tells you the result. It tells, never tells you the inference. Only thing is, this is the null hypothesis. As already I have explained that for any assumption, the null hypothesis is that the assumption is fulfilled. So if we are doing normality test, then we will say that the test data is normal. It is our null hypothesis. So if P is greater than 0.05, this hypothesis cannot be rejected. It has to be accepted. And thus we can say that the test distribution is normal. Is that clear? Because P is 0.200, which is greater than 0.05. Is that clear?
Yes, sir. For small samples, analyze, explore, and what's the third step, sir?
Analyze, descriptive statistics, explore, This select your variable in the plots, normality plot with test. Okay.
Second, analyze descriptive statistics, explore.
Then plots.
Can you just show it once, sir? Little faster. Analyze. Explore.
Select your variable from here. Okay. Plots, normality plot with test.
Yes, sir, clear.
Fine. It will give you
Yes.
Shapiro-Wilk statistic. Okay. Side by
Yes.
side, it will give you KS statistic also, but for a small sample size, focus on Shapiro-Wilk. Shapiro-Wilk is better test than Congress-Wilk. Only limitation is for large sample size, often it gives erroneous result. That's why what I'm saying, whenever you are doing KS test or Shapiro-Wilk test, please cross verify with the graphical method also, whether both are suggesting that the data is normal or not, right? So one is normal QQ plot, another one is the histogram. See, analyze descriptive statistics, select on frequencies, go to variables from the chart, select histograms. The moment you will select histogram, it will ask you an option to show normal curve on histogram. Continue. Okay. And if you see the output, can you see this bell-shaped curve being made with that data?
Yes, sir.
So even through graphical method, you can cross-verify whether your results are coming to be correct or not. Else, change the method. So you can check through graphical method also and through statistical method also. So this is all from my
Sir,
side.
there is one question.
Yes, just a minute, sir.